All right. This is chapter 1. Now, I understand that this material may look like a philosophy class, but here's a problem we get, that our young people go off to college and they have, many of them, particularly if they're studying education or some other courses, they may have to take some philosophy classes. Educational people usually take a couple of philosophy of education classes, and that's a good dose of atheism. I've been there, done that, know what it is. I've been there and done that, so be aware of that. So this first chapter will fit in where logic fits into the overall picture. And then the second chapter from there on will be logic. But I want us to see where everything fits in first. So we have philosophical questions. Philosophers ask a series of questions that are in 3 basic categories. And I believe their questions are good questions. It's just that a bunch of atheists don't give good answers to those good questions. All right, their questions, their categories are reasonable. I believe the scriptures answer these questions, or at least answers of these questions can be derived from a reasonable interpretation of the scripture, good hermeneutics and sound reasoning or logic. I don't believe we should be afraid of seeking answers to these questions, and we'll lay them out and let you see what the categories are in just a moment. But if we look at the idea of philosophy, and most of what's taught in the universities is atheism, atheistic philosophy, we need to define what the word philosophy means. The word philosophy is derived from a Greek word, which means love of wisdom, philosophia. And it's a love or pursuit of wisdom. And what we get into here is this word is found in the New Testament. And so we'll skip down. It's in Colossians 2 and verse 8. So I'm going to read Colossians 2:8. Take heed lest there should be anyone that maketh spoil of you through his philosophy. Now, this is atheistic or a polytheistic probably philosophy at that time. Making spoil of you through his philosophy in vain deceit, after the tradition of men, after the rudiments of the world, not after Christ. So that philosophy was not following the truth. So keep that in mind. Now, what we have here is, he has here pronounced, and that's philosophos, love or pursuit of wisdom, used in the Greek writers, or either zeal for a skill in any art or science, any branch of knowledge. Now, in that sense, this would relate to knowledge of God, and that would come into this as well. And then we have the word in Acts 17:18, this is philosophers. And so this is a philosopher. This is someone that investigates that. That's in Acts 17:18. The study of philosophy is usually divided based upon the Greek words, ontology, epistemology, and axiology, 1, 2, 3. Now, those are fancy words, but we're going to define them in just a minute. Ontology, according to Merriam-Webster, is a branch of metaphysics. We'll have to define metaphysics. And I'll go back and show you what we have. I have a glossary in this book, and I want you to do this for me. If you find a word that you don't know what it means and it's not in the glossary, you let me know and I'll put it in the glossary. We'll get it in there. And there's probably some words that I need to have in that glossary. It's a pretty extensive glossary. And a glossary will define, it's like a dictionary of words. It's got your words that are found there in alphabetical order. Ontology, we'll define it in a minute. Epistemology and axiology. Those are fancy words, but ontology is a branch of metaphysics concerned, and the word metaphysics is defined later, with the nature and reality of things, of being, a particular theory about the nature of being or the kinds of existence. In other words, do we have a soul? Are we just physical? As the atheists tell us, are we just a piece of chemicals, just a bunch of atoms with electrons flying around? Is that all we are? And of course, that gets into the question of ontology. And it's from the Greek word ontos, which we define right here, and I'll highlight it on the screen for you. And it's an adverb. The os ending is an adverb of manner, and truly or in reality a point of fact, as opposed to what is pretended, fictitious or false. So what is real? What is actually real? Is the only thing that's real my body? Materialists say that our body is the only thing that's real. So now we got to deal with this question, and that's where this comes in. Ontology comes into it. How did the universe come into existence? These are questions of ontology. These are real questions, and I believe the Bible answers those questions. And so our question is, can we show from the Bible reasonably answers to these questions? And can we prove that the Bible is God's word and that God exists? If we can establish that, then we've got the basis for arguing that our ontology, our system of explaining what is real, what is not real, is valid or proper. Any questions? Epistemology, then, is defined according to Merriam-Webster. You can type Merriam-Webster on the internet and get a link, and it's free. Merriam-Webster's dictionary, printed dictionary, it's used for college students. It has a lot of the aids in it to help you to use the dictionary. That's not on the link to the internet link. So I have a printed one, but I used that years ago when I was in college. Epistemology is defined, according to Merriam-Webster, as the study of the theory of the nature of grounds of knowledge, especially with reference to the limits and validity. So we're dealing with how do we know things? And how do we know for certain that we know what we know? I say, these are good questions. And so I believe the Bible answers those questions. The word epistemology is derived from epistemi, and here's your definition from Thayer. Now, a lexicon is a dictionary for a particular thing. There are lexicons for medicine. There are lexicons there is even a lexicon you can buy that has all of the words that are in Shakespeare's writings. You can get a lexicon for that. So it's basically a specialized dictionary. In our case, Thayer is a dictionary of the New Testament Greek words. Any questions? Okay. Epistemi, and there's your pronunciation. I put the Greek words in, but I put the pronunciation. Seems to be the Ionic. That's one of the different branches of the Greek language, of the middle of, and the word middle is from the Greek, and we won't explain that. Epistemi, to put one's attention on, fix one's thoughts on, to turn oneself or one's mind, to put one's thought upon a thing, to understand or to know, to be acquainted with, to understand, to know. I believe this is what we're looking at. It's how do we know things? And so what we're going to be looking at in this course is part of what's called epistemology. We're not going to be looking at ontology very much. We may make arguments with our logic on ontological questions, that is, what's real, does God exist, and things of that nature. But we'll be doing it with our epistemology, and that will be our logic. Axiology is a word. It's from the Greek word axios, and it's the study of the nature, types, and criticals of values and value judgments, especially in ethics. How do I know what's right and wrong? Well, I argue the Bible is the only source of determining right and wrong. That's my conclusion, and that's where I stand. And so what we have this is from the Greek word axios, and here's our definition of that word. And again, it's from Thayer as well. There are other lexicons, but I've chosen Thayer. Therefore, properly drawing down the scale. Well, now, if you're going to go buy something, you'll put it on a set of scales, they would, and to weigh the coins or weigh what you're putting on there. So weighing, having weight, having the weight or weighing as much as another thing or like value. So you compare it. it's worth as much. So that deals with what's its value, what's it worth. And so this is the question, for instance, what is good, what is evil, what is beautiful, and so forth. The Bible even tells us what is beautiful. I think a beautiful woman is a woman that serves God. Now, they may physically be beautiful, and your wife is probably physically beautiful, but hopefully she serves God, and that's the real beauty that counts. These three words are summed up in the English words: reality, that's what ontology is, what's real. And we'll be making arguments on that. Truth, that's epistemology. That's what this course is all about. How do we know truth? And value, how do we know what's good and evil, and how do we know what's beautiful, and so forth? We're primarily interested in good and evil. We're going to limit ourselves to studies of epistemology and how do we know things, but we will get off into these other subjects because we're going to use our arguments to show what is good and what is evil and what is real. We'll be arguing for the existence of God and things like that in some of our arguments. Now, unfortunately, many of your philosophers have not followed sound principles of epistemology, and they've drawn unsound conclusions in questions of ontology and axiology. Those are fancy words again. They're questions. They've drawn unsound conclusions about where we came from and how the world came into existence and so forth. And how do we know truth? How do we know what is good and evil? And I'm going to use the word axiomatic, and I'll highlight it here. And of course, that's a self-evident truth. That's all that means. To me, it's axiomatic that there's something wrong with their epistemology, how they know things when they can't agree among themselves. And so there's something wrong somewhere. If we have 100 different positions, it can't be more than one of them right. So if we have 100 different positions, 99 of them have to be wrong, maybe all 100 of the philosophers. So we know at least all of them, there can't be more than one right. Now, this is one of the points we'll draw from logic. Logic is part of the study of epistemology. Most philosophers only allow for two subdivisions of epistemology: deductive reasoning, which is primarily what we're going to study, and inductive reasoning, which we'll get into as one of our latter chapters. And in fact, I believe they're wrong. I think there are four. I argue that there are four ways we know things. And we'll introduce that third way in chapter 2. And of course, I'll let the cat out of the bag. That's by faith. And I believe faith fits in here. And we'll have to define it as we go through it. We're going to confine ourselves to epistemological questions or deductive and inductive reasoning as they relate to ontological and axiological questions. What is real? What is good? What is evil? Now, you have questions, anybody? That finishes chapter 1. If there are no questions, I'm going to go into chapter 2. All right. Now, I want you to do now, we're going to use logic to solve epistemological questions. All right. When we evaluate arguments, it's necessary to first determine how to reason properly. If we don't reason right, we can draw wrong conclusions. One problem in logic or reasoning is that words may have more than one meaning. The word argument, for example, can mean an angry quarrel. And I cite Merriam-Webster, and you can go to that on the internet, find it. I may even have the link down here. It's in blue, and you can click on that, and it'll take you off to that link. All right? But we are not using it in this manner in this treatise. The English word logical is derived from the Greek word logikos, and according to Merriam-Webster. So he tells us where that word comes from. So it's basically from a Greek word. Now, I have a bunch of appendixes. I have through J, A through J, and I may add another one. But the appendixes or where you get a further study on a particular subject. And Appendix A has a discussion of the meaning of this word from various lexicons and various sources. Okay? So it's discussed there, and it's that which is reasonable or rational or logical. And it's essential that we properly define our words or terms or expressions, because when we're talking about different things, we need to be aware that we're all on the same wavelength. We're all tuned into the same channel or the same meaning of the word. So now then, let's look here. Logic can be broken down into two areas of study. The first is deductive logic. Now, I want you to notice here, logic may be defined as a science that evaluates arguments. The word science is probably a bad choice of words there, but we'll leave it alone. That's how Hurley defined it. I cite primarily three logic books. I think Hurley is the best of the three. And if you wanted to purchase one book, I'd suggest Hurley if you can find it. And hopefully it's still in print. The other two are very good as well. They're very useful. All right. But I cite Hurley and Copy and another one. So we'll be citing a third one. So now, deductive logic, an argument in logic, as we're dealing with arguments, occurs in logic is a group of statements, one or more of which the premises are claimed to provide support for or reasons to believe one of the others, the conclusion. That's Hurley's definition. That's what we're talking about. And when we look at these, we're reasoning from a general truth, something that's kind of universally true, to some specific application. For instance, all men have souls. John Doe is a man. John Doe has a soul. So we start with a universal premise, then we draw conclusions from somebody that's in that group or something in that group. Whereas inductive reasoning goes the other way. We'll come to that later. We have 4 or 5 different kinds of syllogism. This is where we put several statements together and form an argument: categorical, hypothetical, destructive, alternative, and conjunctive syllogism. It'll take us a while to get through all of these, but we'll go through them. And the second area, of course, will be inductive logic as we go through it. Now, we're going to consider it later in the book. Now, Copy talks about deductive logic and inductive. On page 32, he says, in deduction, we infer particular from general truths. As I said here, all men have souls. John Doe is a man, so John Doe has a soul. We take it from a general truth, all men have souls, and we said this applies to John Doe, or I'll just apply it to Marion Fox. Marion Fox is a man, Marion Fox has a soul. And so that's a specific truth, a particular. The general truth is all men have souls. The particular truth is Marion Fox has a soul. As I see the difference in general and particular, any question. But with induction, we go the other way. Let me illustrate induction right here for us, just quickly. With induction, we could say, I went to Alaska and I saw 5 polar bears. They were all white. So I conclude that all the polar bears I've seen are white. That's a particular 5 polar bears. And then I see 10 more polar bears, they're white. And so I'm reasoning from the particular, the polar bears I've seen, to all polar bears, I say they're probably all white. See, that's inductive. And that's what we're talking about, inductive reasoning, going from the particular to the general with inductive. Now, science uses induction, right? Now, I would never know about all the polar bears unless I looked at how many of the polar bears. I wouldn't be certain unless I looked at how many. It's a 3-letter word beginning with A and ending with L. Help me out, somebody.
You have to see all of them.
All of them. Once I look at all of them, then I can go from the general to the particular, see? So I'm going to argue that the Bible, later on, I'll let the cat out of the bag, that we can reason inductively from the Bible if we put all of the things it says on a particular topic together. That we have all the information God wants us to know so we can know the answer to that question. Then it becomes deductive reasoning at that point. So if I gather all the facts together, then my inductive reasoning with the Bible, because it contains the universe of information about salvation and so forth, that I can then argue inductively, my inductive reasoning, because I'm looking at all the polar bears, if you please. Now I can reason deductively. Have I given you too much already? Any questions? Jurgensen, I think I had a class with his younger brother, okay? I knew him, his younger brother at the university. He wound up with a he's one, I think he is. He got a PhD in nuclear physics and had all A's all the way through. And he got it at Rice University. He got his bachelor's at Oklahoma State, where I was. But Jurgensen defines deductive reasoning as conclusion based on accepted statements, definitions, postulates, previous theorems, corollaries, and given information. He says the conclusion must be true if the hypotheses are true, assuming that your reasoning is valid. So we have to define valid reasoning, and that's going to be important. Jurgensen defines inductive reasoning. Now we have his definition of both of these. It's a kind of reasoning which is widely used in science and everyday life. Conclusion is based upon several past observations. The conclusion is probably true. See that? Science is probably true, but what? What did it say? Not necessarily true. I'm not knocking science. I just want you to know where it fits in. All right? Barker, our third book, and Barker sets forth one value of deductive reasoning. This is important to us. The point of deductive reasoning is that it helps us to grasp consequences that we had not noticed. So sometimes we can reason from it and we can get a consequence of something we haven't noticed. Let me illustrate this. I'll give a quick illustration. I'll probably put these up. I've got several lessons on this. For instance, Abraham and Sarah were together with Lot. And then Abraham goes down into Egypt. He takes Sarah with him when he goes. The Bible says that Abraham went into Egypt. After he gets there, the Bible says Sarah is with him. Now, he tells her to tell them she's his sister. Conclusion is pretty safe that she probably went with him. Now, there's no mention of Lot going down with him, if you study Genesis. But Lot comes out of Egypt. When Abraham and Sarah exit Egypt, Lot is with them. Now, I do not know for certain that Lot went with Abraham and Sarah when they went down to Egypt. Probably did. But I know he was in Canaan, and before Abraham went to Egypt, and he came out of Egypt with Abraham. What can I say about Lot? I can say for certain that Lot went down into Egypt sometime or another. Is that clear? Is that clear? That's a necessary conclusion. Okay, he was in Canaan, and he came out of Egypt with Abraham. That tells me that it doesn't tell me he went down there with Abraham. Probably did, but I can't say that for certain. But I know he went down there sometime or another because he came out of Egypt. He was in Canaan, and he comes out of Egypt. He had to go down into Egypt. That is unnecessary. That's a conclusion I can draw. So it helps me to grasp consequences that we hadn't noticed. We're going to draw other consequences later. but that were contained in what we probably already believe. And naturally, in more complicated cases, the conclusion might be far more deeply hidden. So sometimes we have to sit down and reason this all out. I've got a series of lessons where I do that and go through implications and see what we find here. Okay. The author, I developed an explanation for some of the fundamentals of deductive reasoning in my book, 2003. I think I sent all of you my copies of my books, electronic copies of them. And if I didn't, you need to let me know, because I'll be referring to these books like Appendix A. That was just a concise, a brief explanation of some of it. You can read that and get a good overview of some stuff. But we're going to go into it in more detail. George Boole and Augustus de Morgan, I believe they were both British, developed an extensive symbolic system of mathematical modes of representing logic. These have formed the basis of a modern electronic computer, and I'll develop these modes a little bit, enough for us to use them, not enough to build a computer by any means. Okay. I won't do it as thoroughly as I did. I taught Boolean algebra for over 30 years in college. That would be the algebra, the logic algebra of computers. Right? Now, let's look at some. Deductive logic has limitations. We need to know the limits of what we're studying. Beginning logic students have problems in understanding the difference between the concepts of valid reasoning and sound reasoning. They confuse them. So we need to look at them. Now, number 6 here tells us that it's an argument such that if the premises are assumed to be true, that's valid reasoning, then it's impossible for the conclusion to be false, right? And sound reasoning is reasoning that is valid and has true premises, right? So we're going to show a series of illustrations to see the difference in those two words. That'll be important because these words are going to be used over and over in this book, or if you study logic, they'll be used over and over. It's confusing to some when they're correctly told that an argument might be valid but not arrive at a true answer. All right, so we'll illustrate it with simple mathematics that you see it. It's also confusing when they're told that an argument might be valid and have untrue premises arrive at the true answer. The answer might be correct. We might draw, with bad reasoning, we might draw a true answer. Our answer might be true. And so that's very interesting. And that kind of confuses people. They just think normally, well, if I do the wrong thing, I should get the wrong answer, not necessarily. All right. So we'll show some illustrations of that where this will be the case, so you can kind of understand. Most students can see how the use of valid reasoning and true premises will give an answer that's true. Most everybody can see that. Most students can also see how the use of valid reasoning and untrue premises could give an answer that was untrue. And they can see that after they learn the difference between validity and soundness. These distinctions constitute the first limitation of logic. Now, I want to start with a simple math equation and illustrate this, that you see the limitation. Now, mathematics is really just pure logic, is all it is. And we're going to take a simple mathematical formula to illustrate it. And we're going to know truth from mathematics. We're going to assume a simple algebra equation, x plus y equals z. About as simple as we can get. If we assume the equation correctly represents some physical process or concept, we can assume that we know the value. If we know the values of variables of x and y, then we can easily get the value for the variable z. All right. Now let's go down to the next page. Let us assume that x plus y equals z, right here, properly represents the sum of the ages of two children. And I've named them Joe and Sue. Why? Because those are short names and it takes up less space in my book. Okay. And I know people named Joe. I have a friend named Joe, and I have a friend named Sue. Okay, so I went to school with two girls named Sue and a couple of boys named Joe. They were both good friends of mine. All right, so, but let's just use Joe and Sue. X represents the age of Joe and Y represents the age of Sue. I'm going to follow through with this. If I add their ages, X plus Y, Joe's age plus Sue's age, I get the total age, the sum of the ages for those two children. See, that's pretty simple. All right. So now Joe is 10 years old. We know he's 10. And Sue is 5 years old. So X is 10 and Y is 5. The correct value for the sum of the ages, sum means you add it, is 15. So if I want to use the correct ages, 10 and 5, and perform the correct mathematics, a correct process, that means a valid process. The valid process to get a sum is to add. So my valid process, I add, and I add 5 plus 10, I get 15. That's the correct age. All right? Any problem with that? I'm going to take the same scenario. We assume, we think Joe is 9 years old when he's really 10 years old. And we correctly have the age of Sue as 5. And we use a valid process. We add to get the sum. And I insert the incorrect age for Joe. And so I add 9 instead of 10 plus 5, I get 14. So now in this case, I used the proper process. I added when I should be adding. My process is valid, but I have now put wrong information in my equation. And so my answer is wrong. So in this case, my process was valid. I added when I should be adding, but I added the wrong numbers. So my answer is wrong. So my process is valid, but it's not sound because all my information was not true. See, there's a difference between sound and valid. Valid is using the right process, and sound is having the right process along with the right correct information. That's the difference. So let's go back and divide it. Valid is when you use the right process. In this case, it's addition. We want the sum, so we add. And it's sound if it's first valid, and then we use correct information in it. All our information is correct. In this case, the ages would be 10 and 5, but we use 9 and 5. So we didn't use one piece of information was not correct. So we got an incorrect answer. Any question about that? That help you to see the difference between valid and sound. All right. Now let us suppose we think that Joe is 9 years old when he is in fact 10 years old. So we got his age wrong. We think Sue is 6 years old when she is in fact 5 years old. We got her age wrong. Now we use the valid process to get the sum, that is, we add. So if we add 6 plus 9, we get the answer of 15. So we use two pieces of incorrect information, and lo and behold, we wound up with the correct answer. Does that help? So sometimes we can use a valid process and some wrong information and draw the right conclusion. In this case, the age was correct, but we had two pieces of information that were wrong. One was 1 year too high and one was 1 year too low, and they canceled out each other, come out with the right answer. So in this case, we used the right process, a valid process, but with bad information, we wound up with the true answer. So that could happen. We see how it could happen with mathematics. Remember, math is just a form of logic. Let us suppose that we incorrectly think that Joe is 20 years old when he is in fact 10. And we correctly think that Sue is 5 years old. So we got his age wrong, but hers is right. All right. Now, If we incorrectly perform the math, we employ an invalid process. When we should get the sum, we should be adding, but we subtract. We use an invalid process. What's the answer going to be now? If I subtract 5 from 20, I get 15. I get the correct answer. So now we've used an invalid process and some bad information, and we get the right answer. So again, the argumentation or mathematics is not sound. And of course, if a teacher was grading the process instead of the answers, he would count it wrong, right? So it's an invalid calculation, subtraction when we should have been adding, but we wound up with the right answer. We obtained the correct answer. The two pieces of information arrived at a true answer by an invalid process. So again, now we have another limitation. The problem we have our knowledge is of two basic kinds. We have knowledge that is absolute and knowledge that is tentative. So we have to ask the information we put in, is it absolutely true or is it tentative? We might have absolute truth in both the premises and the argument and employ valid reasoning, in which case, if we do, the answer is absolute truth. Second, we might have absolute truth in one premise and tentative truth in another. Now, tentative truth, when you look at it, is from the Greek language. The Greek language has two words for if in the Greek language. One of them is tentative if, and the other is absolute. It actually has a structure for this. The Greek language does, which the New Testament was written. We're going to illustrate this in just a minute. But we might have absolute truth in one premise and tentative in another, or we might have tentative truth in both premises. So we got three possibilities, and we got two premises. We could have absolute truth in both of them, and if we use the right process, the answer is absolute. If we have one of the pieces of information is absolute and the other is tentative, the answer is only tentative, even if we use the right process, the valid process. If both pieces of information are tentative and we use the right process, our answer is still tentative. Let's go back to Joe and Sue to illustrate this limitation. For our first example, suppose we know for certain that absolute truth that Joe is 10 years old. And we know for certain absolute truth that Sue is 5 years old. And we correctly add their ages, which is the valid process. Then we have 5 plus 10 is 15. Since both his age is 10 and her age of 5 are absolute, then the answer is absolute truth. We know for certain they're 15 years old. Any questions? All right. Let us suppose that we use Joe and Sue above again for our second example. Suppose we know for certain absolute truth that Joe is 10 years old, and we know that Sue is probably tentative truth 5 years old. And we correctly add, we employ the valid process to get the sum addition, their ages. Since Sue's age is tentative, even though Joe's age is absolute or certain, the answer is only probably true, it's tentative. All we can say is the sum of their ages is probably 15 years old, 15 years. So because his was certain, but hers wasn't, that lets it have an uncertainty in our answer. Let us again use Joe and Sue for our third example. Suppose that Joe is probably 10 years old, tentative. Sue is probably 5 years old, that's tentative. If we correctly add, use the valid process to get the sum, their ages, then we're going to get the answer of 15 again, but we're still not certain that that's the correct answer because we're not certain about their ages. So it's tentative. Now, if we go back and compare the one just before, we were certain of his age, but hers was uncertain, the likelihood that we are wrong in this second one here, this first one had a likelihood of being wrong, but the second one, because both were tentative, probably has a greater likelihood of being wrong than the other one. But we don't know what the probability is of that because we don't have enough information mathematically to figure it. We can just say it's more likely, but we can't say any value, fix any value to it. Let us go to a fourth example now, and we'll go for another couple of minutes, 4 or 5 minutes, and we'll stop. Joe and Sue, let us suppose that we know that Joe is probably 10 years old, tentative. We know for certain that Sue is 5 years old, and we correctly add the process. Since Joe's age is tentative and Sue's is certain, we still have a tentative answer. We use the development process to add, but we still get a tentative 15 years. Now, our fifth and sixth example, I'd like to get through them, then we'll be through. Our fifth example, we're going to assume that we are certain that of the truth of Joe's age. He's 10 years old. This is absolute truth. Then we add some additional information about Sue's age. Let's assume that we know for certain, absolute truth, that Sue is in the first week of kindergarten. All right. This raises the probability that Sue is 5 years old because that's the normal age that you go to kindergarten. So our conclusion that the sum of Joe and Sue's age is 15 years is likely to be true, but the sum is still tentative. We may have a greater degree of certainty about it, but we can't say for certain that it's 15, but it's probably 15 years, the sum of their ages. Our last example here now, and we'll try to go through it quickly. We're going to assume we are certain, absolute truth, that Joe is 10 years old. But we assume that Sue has an older brother who is 10 years old. And so we obtain a range of values for Sue's age. Sue could be newborn. She could be 0. Or she could be a fraternal twin and the younger of the two and be 10 years old. So her age has now a range of values from 0 to 10 years. So the sum of their ages, if we take his age as 10, absolute, and we take the bottom of hers, if she's newborn, it's 0, so the sum would be 10. If we take the top of the range, she is a fraternal twin. She has an older brother, but he's her twin. Then she's 10, so that would make the range from 10 to 20 years. We know the range of some of their ages is from 10 to 20. So we could give the sum of Joe and Sue's ages as 15 plus or minus 5 years. You see how that works? Any question? Now, when we're getting into information like this, what we run into is we see two aspects, and we'll come back to this next week right here. We'll pick up right here. So what I'd like for you to do is I'd like for you to study several pages ahead and be sure and see if you got any questions. Because what we're going to do at the beginning of next class is I want to answer questions. I'm going to have you some assignments to make starting next week. So I'll have some assignments for you to work on starting next week. Are there any questions? Okay.